remaining positive power of the nucleus.
Remaining positive power means the power of the protons, no?
Yeah, I am going to explain that. So first you write the definition. Remaining positive power of the nucleus. Effective nuclear charge is defined as remaining positive power of the nucleus. Now what is the remaining positive power of the nucleus? That I will explain you. In the screening effect we have seen that already, that from as you go from left to right, what happens? One electron increases, atomic number increases by 1. Along with that, when one electron is added, then along with that one proton is also added in the nucleus. Okay, now when electrons are added, they are added in the valence shell mostly, but the volume of valence shell, outer shell, is bigger and volume of nucleus is so small. So positive charge is collected or positive charge is there, which is present in very small volume of nucleus, and electrons are added in the valence shell. So volume of valence shell is bigger and volume of nucleus is so small. So same type of, same number of electrons they are added in the valence shell and same number of protons they are added in the nucleus, but volume of nucleus is so small. Therefore density of positive charge is more compared to the density of negative charge. Therefore hold of nuclear charge on the valence electron, it increases from left to right. So remaining positive power increases from left to right. Remaining positive power increases from left to right. Why? Because density of positive charge increases from left to right, and therefore if you see towards extreme left of the periodic table, which type of elements are present? Alkali metals and alkaline earth metals, right? And they have tendency to donate electrons. But as you go from left to right, then metallic character decreases and non-metallic character increases. What do you mean by non-metallic character? That is tendency to accept electrons increases. If you see, now I will tell you for the second group or for the third group. Suppose if you take NaMg, Na Mag Alasi Pasakala Ar. Do you know this? आता हे पाठ झालंय ना सगळ्यांचं? All of you know this. नामग आलसी पसकलर. Now नामग alasi. So up to this they are metals. Now this is metalloid, and these three are non-metals, and this is inert gas. Now what happens from left to right? They have tendency to form cations and they have tendency to form anions. They always, non-metals accept electrons. Why they can accept electrons? Because remaining positive power of the nucleus increases from left to right, therefore they can hold more number of electrons. But in case of metals, valence electrons are loosely bounded, therefore they can donate electrons easily, but non-metals can hold more number of electrons, therefore they form anions. Why it is so? Because remaining positive power of the nucleus increases from left to right. Why remaining positive power of the nucleus increases from left to right? Because protons are added in very small volume, therefore density of positive charge increases from left to right, and with that number of valence electrons are added, but valence electrons are added in the bigger volume because valence shell is big and nucleus is so small. Therefore effective nuclear charge increases from left to right. Effective nuclear charge is inversely proportional to the screening effect. Try to understand, this is very important. Effective nuclear charge is inversely proportional to the screening effect. Now what happens down the group? Down the group, same story again. That is, atomic number increases, nuclear charge also increases. So remaining positive power should increase, but increase in number of shells dominates over the increase in nuclear charge. So number of shells are added, therefore ENC decreases down the group because number of shells are added. Screening effect and ENC, they are inversely proportional to each other. So down the group, screening effect increases and ENC decreases. Have you followed that? Now all of you write the explanation of this effective nuclear charge. I have given you only definition. So all of you write now explanation. Write down from left to right. Okay, from left to right, atomic number increases one by one. Electrons are added in the valence shell. Along with that, nuclear charge, along with that nuclear charge also increases. Along with that nuclear charge also increases. But volume of valence shell is bigger.
Can you repeat this?
Volume of valence shell is bigger compared to nucleus. Therefore, positive charge density, in the nucleus.
Ma'am, can you repeat from positive charge?
Ma'am, can you
Positive
repeat this
charge
point?
density.
Can you repeat this point from beginning? This point.
अरे आता मी माझ्या मनाने सांगते, त्यामुळे कोण लिहिले असेल तर त्यांना सांगा करायला.
मॅम नाही, पॉझिटिव्ह चार्जच्या पुढचं सांगा ना.
Remaining positive charge density in the nucleus increases more fast or more rapidly.
Ma'am, positive charge density in the nucleus
increases more fast or more rapidly compared to negative charge density. Compared to negative charge density. Therefore, remaining positive power
Ma'am, can you repeat from faster or rapid? More faster, more rapidly.
more fast or rapidly. Therefore, remaining positive power of the nucleus increases from left to right. Therefore, from left to right, ENC increases. This is more important. Put this in rectangle. From left to right, ENC increases. This is the trend in this property. We are studying trends in periodic properties. What happens from left to right? What happens down the group? Now write down explanation. Now this is the first point. You write first point. That is what happens from left to right. Now second point you have to write down the group. Write down the group. Now write explanation for this. Down the group, atomic number increases. Therefore, nuclear charge also increases. But new shells are added. Therefore, even though nuclear charge increases, remaining positive power decreases. Therefore, down the group, ENC decreases. And very important point you write, ENC is inversely proportional to the screening effect. Write down this, very important. ENC is inversely proportional to the screening effect. They followed now both the properties, both the trends, screening effect as well as effective nuclear charge. In short, I will tell you again. Now first we will see about screening effect. Left, right, what happens? New electrons are added in the same shell along one by one. Now imagine from left to right. Atomic number increases one by one. So valence electrons are added into valence shell one by one. Along with that, protons are also added one by one. So nuclear charge also increases. But what happens from left to right? What happens about the screening effect? The distance between nucleus and valence shell decreases because hold of nucleus on the valence electrons is more. Therefore, valence shell is pulled inside. Okay. Therefore, screening effect decreases. Kedar Yadav, are you paying attention? So, what happens down the group about screening effect? Tell me.
Ma'am, can I tell?
No, Kedar Yadav will tell now. Hello.
Ma'am, he can't speak up. He's speaking, but we can't hear him.
Your voice is not audible.
Mine?
Yes, your voice is not audible.
Ma'am, your voice is audible for me.
Yes, ma'am.
It's clear.
केदार यादव चा हे नाहीये, ऐकायला येत नाही तो काय बोलतो ते.
Sir, in middle your
Okay,
voice was not
who
coming.
will explain about the screening effect? What happens down the group? Who will explain that? Tanvi, huh? Tell.
Ma'am,
Hello,
so
ma'am.
down the group.
Huh?
Ma'am, do I start?
Huh? Yes.
Ma'am, so down the group, the atomic number increases, and along with that, the nuclear charge also increases. So the
Correct.
force of attraction increases, but along with the increase atomic in the atomic number, the new shells are also added, and the distance between nucleus and valence shell increases. Hence, impact of nuclear charge on the electron decreases, and hence the screening effect also increases.
Screening effect increases. Right.
Yes.
So, what is the conclusion about screening effect? That is from left to right screening effect
Decreases.
Increases.
and down the group screening effect
Increases.
Decreases.
correct. And screening effect and effective nuclear charge, they are inversely proportional to each other. And what is ENC? ENC is remaining positive power of the nucleus. So from left to right, ENC increases. Down the group, ENC decreases. Because screening effect and ENC, they are inversely proportional to each other. Now we will proceed further for the next property. That is third property. Third property is atomic size. Okay. Now in atomic size, we have to consider atomic radius. How will you measure atomic size? By considering atomic radius. Now there are types of atomic radii. Radii is the plural form. So types of atomic radii. Radii is the plural form of radius. So first type is covalent radius. Now what is covalent radius? Covalent radius, the radius, atomic radius which is measured in case of covalent compounds.
Ma'am, can you repeat?
Covalent radius is the atomic radius which is measured in covalent compounds. Now here you have to understand very important thing, that is to measure radius of a single atom is very difficult because it doesn't come in the doesn't come in the visible wavelength, visible frequency or visible wavelength. Therefore we can't measure the radius of single atom. Now in case of covalent compounds, I will give you one example. Example is hydrogen molecule, H2 molecule. Now only hydrogen atom doesn't exist in the nature. It exists in its molecular form, H2 molecule. Okay, here it is molecule. You can write the spelling of molecule, H2 molecule. Okay. If we want to measure radius of single hydrogen atom, then it is very difficult. But we can measure the internuclear distance. Now this hydrogen molecule, we can write it as, we can represent as this, HH. this single line, whatever is line I have drawn over here, it indicates the covalent bond. It is a symbol of covalent bond. All of you keep your videos on. So HH. So this single line is indication of covalent bond. Okay. Now suppose if
Ma'am,
I
actually,
give
I have
you,
an internet issue, so can I keep my video off?
okay, if now this is
Hello?
the diagrammatic representation of hydrogen molecule. This is one hydrogen molecule, second hydrogen molecule. One hydrogen molecule, one hydrogen atom is having one electron. Now this dot is electron, and second hydrogen atom. Now there is a difference between atom and molecule. Try to understand. Hydrogen, if it is single hydrogen, then it is atom, and H2 is molecule. Followed? Atom is the smallest particle of an element which may or may not have independent existence. That is the definition of atom. Have I given you before? And molecule is the smallest particle of compound which is having independent existence. So H2 molecule is having independent existence, but not hydrogen atom. So it is very difficult to measure the radius of single hydrogen atom. Therefore, scientists discovered that if we take internuclear distance, now these two are electrons and they are shared between two atoms. This is how covalent bond is formed. Covalent bond is formed by sharing of electrons. Because one hydrogen atom is having, how many electrons are there in one hydrogen atom?
One.
One. Correct. Very good. But if any atom completes its duplet or octet, then only it becomes stable. So hydrogen, when it forms hydrogen molecule, then only there is stability for the hydrogen. H2 molecule is stable. Okay. So both hydrogen atoms, they share one electron, and therefore covalent bond is formed. And therefore this is the structure of H2 molecule. Now what we have to do? We have to measure internuclear distance. We have to measure internuclear distance. Here. Now this is the internuclear distance. What do you mean by internuclear distance? It is the distance between nucleus of two atoms. Nuclei, you can use the word nuclei because nuclei is plural form. So internuclear distance is the distance between two nuclei. So suppose if this distance is d, then radius of hydrogen atom is equal to d by 2. So in general radius, here we have taken example of hydrogen molecule. Therefore, I have written radius of hydrogen. But in general, R is equal to d by 2. This is very important formula in case of covalent radius. So what is the concluding point? Covalent radius is measured in case of covalent compounds. How covalent compounds are formed? By sharing of electrons. H2 molecule is example of covalent compound. Now, how to calculate radius of hydrogen atom? We can calculate radius of hydrogen atom by measuring internuclear distance in two hydrogen atoms in a molecule, and therefore radius of hydrogen is equal to d by 2. Now you will tell there is overlapping, so it is not perfect radius. Suppose if I tell you this is the hydrogen atom, so the radius is this, radius of hydrogen atom is this, but there is overlapping. Now how it is possible? Okay, but the thing is that we can't measure radius of single hydrogen atom. That is the main drawback. That is the main difficulty. Because hydrogen atom can't exist in single as a single hydrogen atom. Therefore, we have to measure internuclear distance between two hydrogen atoms, and that is possible in hydrogen molecule. Therefore, we can determine radius of hydrogen atom like this. Now, you will say that there will be some difference, but whatever overlapping region is there, that is very, very negligible. Okay, considering total volume of hydrogen, whatever overlapping region is there, that is negligible, so it is neglected. So whatever internuclear distance is there divided by 2 is the radius of one hydrogen atom. Followed or not? Followed all the things. Now write down explanation. You have to draw this diagram.
Which diagram? That.
This diagram, this diagram. And whatever
Okay.
I have
Yes,
written
that
on the
covalent
screen,
bonds one, right?
huh?
That.
This also, this also. If you
Okay.
want to write this, but it is, if you can't do this, that is a problem. So except this, you can write all the things. Huh.
मॅम या डायग्राम मध्ये ते दोन ब्लॅक डॉट्स काय रिप्रेझेंट करतात?
White dots, black dots,
ब्लॅक डॉट्स त्या डायग्राम मध्ये
electrons. Hydrogen is having one electron. Second hydrogen is having one electron. So they share their electrons and they form covalent bond. But is it possible to write always this diagram? No. So we represent like this in simple way. This is the simple way of representation. Or mostly we write H2 molecule. This is the structure of H2 molecule, you can say. Okay, so black dots you don't write more than 2. This is not Tipkanchi Rangoli. You have to measure how many dots are there. You have to count because they represent what? Anushka Kulkarni. What is the significance of black dots?
Ma'am, they are electrons.
Correct. How many electrons are there?
Ma'am, can I tell?
Are you Anushka?
No.
So Anushka will tell. I have asked to Anushka. Huh. How
One
many?
in each atom.
Huh?
One in each atom.
One electron in each atom. So if these two electrons represent what? Now who was telling before? Tell.
These two electrons represent that since the atoms, like the diagram which you have drawn, the two circles are overlapping, and since the circles represent atoms, which means that the electrons are being shared, so they are attaining the duplet state.
Yeah, बरोबर आहे. So that is the overlapping region. That means by sharing of one electron each, covalent bond is formed between two hydrogen atoms. And this is how hydrogen molecule is formed. But our focus is on what? Our focus is how to measure the atomic radius of hydrogen atom. So we have measured internuclear distance. Internuclear distance. What is internuclear distance? Distance between two nuclei. And then divided by 2, you will get radius of hydrogen. Now write down explanation for this. Covalent radius is measured in Sherville. Write down. Covalent radius is measured in covalent compounds. It is very difficult to measure radius of single atom. Because atoms are highly reactive they
Ma'am,
do not
atoms are
exist.
highly
Reactive. Atoms are highly reactive, and also it is very difficult to measure radius of single atom. In the
Can you
next
just
line you
repeat
write,
once? 1920.
it is very difficult to measure radius of single atom. In the next line,
आपण आपण वाक्यामध्ये it is very difficult to measure radius of single atom because atoms are highly reactive. Because also it is difficult to measure radius of single atom लिहिलंय. So like ते दोनदा आलंय. ती phrase दोनदा आली आहे.
ओके, ते मध्ये मध्ये असं काय काय बोलतात ना, त्याच्यामुळे ते असं होतं. ठीक आहे, इट इज डिफिकल्ट टू मेजर. यू कॅन ऍडजस्ट अकॉर्डिंग to your own language. Okay, it is very difficult to measure radius of single atom because atoms are highly reactive and actually they are not exist in free state. You write accordingly according to your own language. They do not exist independently, but there is again exception of inert gases. तुम्ही ऍडजस्ट करा वाक्य. ओके,
मॅम तर मेटल्स मध्ये किती atoms लागतात एक मॉलिक्युल बनायला? म्हणजे
तू
ते
पहिल्यांदा
पोटॅशियमला
व्हिडिओ ऑन कर.
नाही मॅम ते नाही होत. मॅम आता बघा ना, म्हणजे आता बंद केलंय मी. आता मी सुरू केलं तर तो साईन येतो, तो नॉन कॅमेराचा.
बरं ठीक आहे, बोल आता काय बोलायचं तुला.
मॅम तर ते मेटल्स मध्ये किती लागतात? हाऊ मेनी atoms do you need to create a molecule? Metals
So
मध्ये.
it depends upon, it is completely dependent upon their valency. Okay, it depends upon valency. It is not like that. There is no means perfectly it is depend upon their valency. For example, I will give you one example. Suppose NaH it can form, but if it is Mg, then you need two hydrogen atoms. If it is L, then it is LH3 because valency of Na is 1, so one hydrogen atom is required. Mg is having 2, so two hydrogen atoms are required. L is plus 3, so three hydrogen atoms are required, like this. So it depends upon valency.
Okay, ma'am.
Now in the next line you write, therefore to measure, and don't talk in between unless and until I complete the statement. Okay, therefore to measure atomic radius, internuclear distance, internuclear distance between two atoms is measured. And half of the internuclear distance and half of the internuclear distance is considered as radius of an atom. One more thing is that, no, you don't write that. One more thing is that I have told you one point, that is atoms are highly reactive. They do not exist in free state. Also, they don't come in the range of visible wavelength. That is also point. They don't come in the range of visible wavelength. So we can't measure the distance. Now internuclear distance we can measure. Why? Because H2 molecule is having independent existence. So we can measure the internuclear distance, and half of the internuclear distance is the radius. Now I will tell you one more example. Now H2 molecule is one example. Now we'll see second example, that is O2 molecule. O2 molecule. O2 molecule is oxygen molecule. Now in case of oxygen, there is double bond between two oxygen atoms. There are two lines. So covalent bonds are of three types. I am not teaching you covalent bond. We are focusing here how to calculate or how to determine radius of an atom. But this is double bond which is formed between two oxygen atoms. Okay. Covalent bonds are of three types, that is single bond, double bond and triple bond. Only three types are there. Single bond can be formed, or double bond can be formed, or triple bond can be formed. Hydrogen molecule is example of single covalent bond. Oxygen molecule is example of double covalent bond. Now
And
how
then
double?
carbon should be able to form all three. No?
Huh?
Then carbon should be able to form all three.
Carbon doesn't form four. It forms single covalent bond only. It depends upon valency again. Carbon is having four valence electrons. So it forms four single covalent bond. Or it can form sometime double bond also or triple bond also. Carbon is having three types. Okay. So here we have to write now. See, these dots represent electrons. So when two electrons are shared by each oxygen atom, two electrons are shared by each oxygen atom. This is how oxygen molecule is formed. So this is one oxygen atom, this is second oxygen atom. So this is the diagram of O2 molecule. Two electrons are shared by each atom. Now suppose this is the nucleus of one oxygen atom, nucleus of second oxygen atom. Again the same thing. You have to measure the internuclear distance. Okay, that is D. You have to measure internuclear distance. Then what is the radius of oxygen atom? That is d by 2. So in general, what is the formula of radius, covalent radius? That is r is equal to d by 2. That is general formula. R is equal to d by 2 is general formula. Okay. Now third example I will give you. For example, N2 molecule.
मॅम
Hmm.
मॅम
Hmm.
हे तर म्हणजे ऑक्सिजन ॲटम म्हणून एक्झिस्ट करतं ना, त्याला आपण ऑक्सिजन ओ असं लिहितो आणि ब्रॅकेटमध्ये टाकतो.
हो, तो nascent oxygen. That is called a nascent oxygen atom. But that nascent oxygen atom is highly reactive and it is having life equal to only fraction of second. It forms, but immediately it combines with other atoms and it goes. So that is intermediate stage, but that is for very, very little time period, fraction of second only. Okay. So it is very difficult to measure the radius. So in O2 molecule, we can measure by taking now you have followed the concept. How to measure covalent radius? You have to take internuclear distance, and half of the internuclear distance is radius. Now in case of N2 molecule, it forms 3 covalent bonds. So 3 electrons are shared. One covalent bond is formed by sharing one electron. So covalent bond, to form covalent bond, 2 electrons are needed, one from each atom. So 3 electrons are shared. So N2 molecule is like this, N triple bond N. Now again you have to measure internuclear distance, and this is D. Internuclear distance is D. Therefore Rn is equal to D by 2. So this is called as covalent radius. What we are doing now? We are doing atomic size. Atomic size, to measure atomic size, atomic radius is measured. And there are many types of radii. Radii is the plural form. So first we have seen covalent radius. Followed? I have drawn the diagram. Explanation is same. I have given you 3 examples. H2 molecule, O2 molecule, N2 molecule. Okay. Now we'll see van der Waals radius. Second type of radius is van der Waal.
Ma'am, carbon can form all 3 types, right?
Yes. Now see, in organic chemistry, there are compounds like alkanes, alkenes and alkynes. So in case of alkanes, carbon forms single covalent bond. In case of alkenes, carbon form double bond. In case of alkynes, carbon form triple bond. You don't have that organic chemistry now. Now we'll see what is van der Waals radius. Van der Waals radius. This is new name for you. Van der Waal radius. Now van der Waals radius is measured when there are van der Waal forces.
Like between graphite, no?
Yes, the sheet-like formation.
Yes, ma'am, that only.
But that is different. The van der Waal forces are there. But with that we can't measure radius of carbon atom. Those van der Waal forces are between hexagonal sheets. Those van der Waals forces are not between atoms.
Yes.
Now see, in case of graphite, what happens? I will clear your concept. Now see, in case of graphite, these are the hexagonal sheets. Okay. Now on each corner, carbon atom is present. Each corner, carbon atom is present. So whatever these hexagonal sheets, whatever these lines are there, na, ह्या lines आहेत, these lines, they represent covalent bond. There is a single covalent bond between carbon and carbon. But van der Waals forces exist between hexagonal sheets, 2 hexagonal sheets. So hexagonal sheets are bounded together with the help of van der Waals forces. So between 2 atoms, it is not this thing. What van der Waals forces? Van der Waals forces do not exist between carbon atoms. They exist between hexagonal sheets. So if you want to find out radius of carbon atom, then you have to consider covalent compound of carbon. Then only you can find. That example we have not taken. We have taken 3 examples: hydrogen, oxygen and nitrogen. Now, van der Waals radius, van der Waals forces. Now see, these are the van der Waals forces. They are weak forces. They are very weak forces of attraction. Write down. Van der Waals forces are very weak forces of attraction which exist between inert gases. Which exist between inert gases. Now, suppose if you take helium gas. Helium gas is example of inert gas. Now, all of you know that what is the property of gas? Gases occupy all the available space. That is the property of gas. Gas occupies all the available space. Now, always radius is measured. In any case, radius is measured when atoms are close to each other. Then internuclear distance is measured and then radius is found. Radius is calculated. Now, when helium gas will be two atoms of helium, when they will be close to each other. Now, if we apply pressure, if we increase pressure and decrease temperature, if we increase, suppose in one container there is helium gas, so if we apply pressure on that, then volume will get decreased, then those atoms will come close to each other. Also, if we decrease the temperature, then the atoms will come close to each other. When they will be maximum close to each other, then internuclear distance is measured, and then again half of internuclear distance is the radius of that helium gas. Now see, when we okay, I will explain you in more elaborating form. Suppose these are two helium atoms, but there are many helium atoms. If you take one container, atoms are so small, so there are million number of helium atoms, but for understanding purpose I have drawn two. Suppose this is helium atom and this is another helium atom. So this helium atom is having positively charged nucleus and this another helium atom is having positively charged nucleus, and there are electrons. In case of helium, there are two electrons. Now in any type of atoms, if they come close to each other, there are two types of forces exist. There is repulsion between electron and electron. They repulse, R represent repulsive force. There is repulsion between two nuclei because electron and electron, they are same, they are having same charge. So there will be repulsion. Between nucleus of one atom and nucleus of another atom also there is repulsion. But attractive forces is there between, will you tell me where attractive force will be between what?
Between protons and electrons.
Yes,
Opposite
but,
charges.
yeah, but
Opposite
nucleus of one atom and electron of other. So force of attraction will be nucleus of one atom and electron of other and vice versa. Again, like this. So these are the attractive forces. Repulsive forces exist between electrons of two atoms. Repulsive forces exist between nuclei of two atoms. But attractive forces exist between electron of one atom and nucleus of other, and vice versa. Now as these atoms, they come close to each other, then attractive forces start operating. Okay, but there is again limit for that. When they come very close to each other, then again repulsive forces start operating. So when they are maximum close to each other, then internuclear distance is measured. So suppose this is one helium atom and another helium atom. So they can't form bond with each other because helium is inert gas. Its duplet is complete. It's not like hydrogen molecule. There will be no overlapping of atomic orbitals. They do not form bond. But when they will come maximum close to each other, at that point you have to measure the internuclear distance. So there is some limit for that. When they will come close to each other, we have to apply pressure on that. When we increase pressure and decrease temperature, then they will come close to each other, then attractive forces start operating. They will come close to each other, but there is some limit. After that limit, they will start repelling with each other because repulsive forces exist. Repulsive forces will be dominating. That is, repulsive force will be between electron and electron. Repulsive force will be between nucleus of one atom and nucleus of another atom. Followed or not? Who has followed? Who will explain this again? And Advait Bhartiya raised hand. What is your
Miss, I have a question.
Tell.
I have a question. Miss, if proton is the attracting force of the electron, then why doesn't the electron just stick to the nucleus instead of orbiting?
I didn't get. Who has followed? Tell me what he is saying. Hello.
Miss, I'm saying that if the electron is the proton is the attractive force of the electron, then why does the electron move around and not just in a cloud and not just stick to the nucleus, the proton?
Why they move?
Yes, miss.
They move around the nucleus. That is going on in each atom. But when two atoms are curved, when we are studying the case of when two atoms come close to each other, then what happens? Actually, this is going on. This is continuously going on.
Thank you.
See, Earth revolves also and it rotates also. So similarly, electrons revolves also and this atom rotates also. And when they come close to each other, then these forces start operating. Repulsive as well as attractive forces. So when we increase the pressure, decrease the temperature, then attractive forces start operating. But there is some limit again. When they come close to each other, then they at some point they will start repelling. So when they will be maximum close to each other, then we have to measure internuclear distance, and it is d by 2 again. R is equal to d by 2. Okay. Write down explanation for this. I have given now van der Waals forces are weak forces and they exist in inert.
Yes, ma'am.
Yeah. So write down explanation now. In case of inert gases, when we increase pressure, and decrease temperature, Then
Can you repeat from decrease?
when we increase pressure and decrease temperature. Tanish Gharge wants to record.
Ma'am, here is too much loud noise, so can I record and hear afterwards?
ठीक है, no problem. So tell me what I said.
Recording in progress.
What is the statement you have written?
In case of inert gases, when we increase pressure and decrease temperature.
Then inert gas molecules. Inert gas are also called as molecules. They are called as monoatomic molecules. In case of inert gases, molecules and atoms are same only. So inert gas molecules come close to each other. At that time, attractive forces start operating. Attractive forces start operating. Attractive forces are present between nucleus of one atom and electrons of other atom. But there is some limit. When they come very close to each other, then repulsive forces start operating. Repulsive forces are there between electrons of two atoms and nuclei of two atoms. In the next line you write, when two atoms of inert gases are maximum close to each other, then internuclear distance is measured. Then internuclear distance is measured and half of internuclear distance is considered as radius of inert gas. For example, helium gas. Have you drawn these figures? Whatever I have written over here. Yes. All of you draw it. This you have to draw this helium for helium. Okay. And you have to draw this for attractive and repulsive forces. Don't draw this. So complete this.
Ma'am, I have a doubt.
Hello. Have you completed?
Ma'am, I have a doubt. So, you wrote, like you told us to write for van der Waals radius, the forces are weak, forces of attraction, which exist between inert gases.
Correct.
Yeah. So, but like you mentioned, in case of graphite, is considered for the whole hexagonal structure. So that's an exception for that, right?
That is completely different. Now, between hexagonal sheets, there is van der Waals forces. That is different. But van der Waals forces is weak force of attraction that is there.
Yeah.
But here, what I want to tell you, between inert gases, there are van der Waals forces of attraction.
Okay, so like
when inert gases they are very close to each other, then van der Waals forces exist in inert gases.
Okay, so
And
like that's a different topic.
Yeah.
Okay.
So you should correlate. You can write one more line, that is van der Waals forces exist, but I have given now van der Waals forces
Yes, ma'am. Yes.
exist in inert
Yes.
gases.
Yeah. Thank you, ma'am.
Okay.
मॅम पण ही डिस्टन्सेस मेजर कशी केली जातात?
ते आता सायंटिस्ट मेजर करतात with the help of spectrometer.
And ma'am, one more question: that are these distances fixed for every, or they're different for every atom and one molecule in one?
That is different, yes. But in general, we can say that van der Waals radius is bigger compared to the covalent radius. Have you followed that point? Because in case of covalent radius, when we measure, then what happens? Overlapping takes place between atomic orbitals. And here there is little bit distance between two atoms, because they can't overlap inert gases.
Ma'am,
okay.
So how many examples are of the covalent
Many.
molecules?
There are many. Whatever covalent compounds are there, then if we measure the radius, these are covalent radius only. In case of inert gases, van der Waals radius is
Okay,
there.
ma'am.
Okay. So all of you write. Van der Waals radius is always greater compared to the covalent radius.
Ma'am, can you repeat once?
Van der Waals radius is greater compared to covalent radius. So we have seen two types of radii, covalent and van der Waals radii. Now next is metallic radius. Third type is metallic radius. Now as the name itself indicates that metallic radius is measured in case of metals. So metallic radius is measured in case of metals. Now all of you write, metals form crystal lattices. Metals form crystal lattices. Do you know the spelling of lattices?
No.
Yes.
Metals form crystal lattices.
Can you tell the spelling?
Yeah. La. Metals form crystal lattices. Lattices is the plural form. Now, what is crystal lattice? Crystal lattice. It is specific arrangement. Write down. Crystal lattice. It is specific arrangement Some students are not writing. Aditya,
Is specific.
are you writing? Some काय सांगितलं मी? Some
Crystal lattices have specific arrangement.
crystal lattices are having specific arrangement of atoms, molecules or ions. Okay. Now in crystal lattice there is 3D structure, that is 3-dimensional structure. 3D structure is there. 3-dimensional structure. Okay. Now in 3D structure there is one repeating unit. There is one repeating unit which is called as unit cell. Now this topic is little bit difficult to understand, but I will explain you and you will understand it definitely. Now see, metallic radius is measured in case of metals. Metals are having crystal lattice. What is crystal lattice? Crystal lattice is specific arrangement of atoms, ions or molecules. And those crystal lattice, suppose if you imagine, do you know khade meat? Solid salt is there, or
Yes.
khadi sakhar is there. So how those crystals are there? So it is like a cube. Okay. but in that many molecules are there, because atoms and molecules, they are so small. So those you can imagine. So this is the structure of crystal lattice. So there is a specific arrangement of atoms or molecules or ions, and in that one repeating unit is there. That unit is repeating again and again and again and again. Suppose if you imagine very big cube, then very small cube is there, and so many cubes are repeating again and again. It is like that. Or you can imagine what you play, that
Rubik's Cube.
Rubik's cube. Yeah, it is like that. You can imagine crystal lattice like that. So it consists of many cubes, na? So that cube, one cube is called as unit cell. It is a repeating unit. It repeats again and again. Okay. Now there are again types of unit cells. There are many types of unit cells. So any crystal lattice, it consists of one repeating unit. That repeating unit is called as unit cell. Now what are the types of unit cells? First is, it is monoclinic. Then triclinic. Okay, you write this 2 and 3. So first is cubic, monoclinic, triclinic. Then rhombohedral, then orthorhombic, tetragonal, and hexagonal. Hello. So there are 7 types of unit cell. There are 7 types of unit cell. Cubic, monoclinic, triclinic, rhombohedral, orthorhombic, tetragonal, and hexagonal. So have you completed all those? Now we have to focus only on cubic. Actually, this is a very vast portion you will be having in 11th and 12th. All this crystal lattice and what are the types of unit cells and all that. We'll study only about the cubic type of unit cell. Now see, these repeating units are called as unit cell. So those unit cells are also having different type of structure in metals, different metals. So if it is cubic, then what will be there? So have you completed this? Have you written the names of 7 types of unit cells?
Yes, ma'am.
So first is cubic unit cell, or you can say cubic type. Crystal lattice.
मैम 1 मिनिट बाकी स्लाइड तक
ठीक है.
झालं.
Okay. So in cubic unit cell also there are again 3 types. Again there are 3 types. Okay, so first is simple cubic cell, which is called as SCC, simple cubic cell. So before I start simple cubic cell, again I will tell you the whole story so you will not confuse. First thing is that we are studying about the atomic size. To learn atomic size, what we have to do? We have to measure atomic radius. Then we come to know what is the atomic size. Okay. Then in that again we are learning about different types of atomic radii. What are the different types of atomic radii? First we have learned about covalent radii. Then we have learned about van der Waals radius. And third type is we are learning about the metallic radius. Now covalent radius is measured when covalent compounds are formed. So when there is atomic overlapping, then only atoms are more close to each other, and then internuclear distance is measured, and half of the internuclear distance is covalent radius. We have seen 3 examples: hydrogen molecule, oxygen molecule, and nitrogen molecule. Then we have learned about van der Waals radius. Van der Waals forces exist in inert gases, because inert gases do not form bond because their duplet and octet is complete. So then they don't form any bond. They are inert. In case of helium, duplet is complete. Other than helium, octet is complete. So they don't form any type of bond, not covalent, not ionic, not any type of bond, not any type of overlapping. So what is the situation? That is when they are maximum close to each other, then we have to measure the internuclear distance. When they will be maximum close to each other? When we increase the pressure, decrease the temperature. But again, I have told you the whole story that when they will be at maximum close to each other, that is there are attractive forces, they will come close to each other, but again repulsive forces start operating. So there is some minimum distance. They that point only At that point only they will come close to each other. After that they will not come close to each other. So when they are at maximum closest, then we have to measure internuclear distance. That will be the uh, internuclear distance divided by 2, you will get radius. That is called as van der Waals radius. Now third type is metallic radius. In case of metals,
And since the inert gases are balanced, then it is possible to reduce pressure, increase pressure and reduce temperature, and they come close.
balance means what?
Means the atoms of inert gases are balanced, right?
Balance, no, that word is not suitable. They are stable.
Okay.
Not balanced, they are stable. They are not reactive because they are inert. Why they are inert? Because their duplet and octet is complete. Therefore, they don't form bonds. But now see what I said to you, that is the property of gas is they will occupy all the available space. But when they are now, see, suppose helium molecule is here in this room, suppose helium molecule is here, then it is in this corner, then how to measure internuclear distance? They should come close to each other. Then only we can measure radius. Therefore, we have to apply pressure. Suppose for helium gas, we have to put helium gas in one container, and then we have to apply pressure, we have to decrease the temperature, then they will come close to each other. But there is some limit. They can't overlap, they can't form bond. Otherwise, if they cross their limit, they will start repelling. And when they are maximum close to each other, at that time we have to measure the internuclear distance. That is the point. Okay, so that is the story of van der Waals radius. Now we have started the story of metallic radius. Metallic radius, the name itself indicates that it is measured in case of metals. Now, what is the structure in case of metals? Inside, we are studying at microscopic level. So, they consist of crystal lattice. Metals consist of crystal lattice. Now, crystal lattice is the specific arrangement of atoms, ions, or molecules. Now, in crystal lattice, again, one unit is there, specific unit is there. That unit repeats again and again. It's called as
Recording stopped.
you can imagine from that. It consists of very, very small cubes. Okay, Rubik cube. So it is like that. That is, you can imagine it is the structure of crystal lattice. So that repeating unit is called as unit cell. But again, unit cells are also having different types. 7 types I have given now.
Yes,
Yes, ma'am.
Yes.
So unit is structure. So in some structure, in some metal there is rhombohedral type of structure. In some metals there is a triclinic, or in some metal there is monoclinic, like that. So it depends upon the unit cell. Now it is very vast to learn. So we are focusing only on the simple cubic cell. Simple cubic cell is SCC. What is the structure in simple cubic cell? Now I will draw the diagram. All of you have to pay attention. Now see, simple cubic cell is like this. Now suppose, now this is the easy way how to draw the cube. You have to draw these two squares and join them like this. So the cube. Okay. Now at each corner one atom is present. How many corners are there for cube? 8. So 8 atoms are present.
8, ma'am.
Correct, correct. So 8 atoms are present at 8 corners. This is the structure of simple cell. Now see, again in we have chosen one unit cell, one type of unit cell, that is a cubic cell. Again in cubic cell there are 3 types. That is 3 types I have. Okay, I will write. SCC is there, that is simple cubic cell. FCC, face centered cubic cell, face centered cubic cell. Then BCC is there, that is body centered cubic cell. These are the 3 types of cubic cell. So from that we are considering simple cubic cell. So at each corner one atom is present. Now this is the cube. Okay, and at each corner one atom is present. They are maximum close to each other. In unit cell they are maximum close to each other. These are the 4 atoms. Suppose तुम्ही असं वरून बघितलं from top view, you can see 4 atoms which are close to each other. Followed or not?
Yes, ma'am.
Okay. Now here again you have to measure this distance, that is A. This distance is A. A is the edge length. Now this is the edge length A, but distance between center of 2 atoms is again A. Yeah, because it
Any
comes edge
specific
length.
reason?
Now see, no, this is the center of the atom. This is the center of atom. So distance
Yes.
between centers of 2 atoms is the edge length of the cube.
Yes.
A is the denotation. A is the symbol for
Okay.
edge length. we use the symbol A.
Means
Okay.
A is the internuclear space now, like that.
I heard age
Yeah,
length.
yeah. Yes, internuclear distance is age length only. So R is equal to A by 2.
Ma'am, means they are very close to each other. They are very close to each other and they overlap.
They don't overlap actually. They are only, no, here you have to write, okay, you write like this. They don't overlap. Write like this. So mistakenly it is like, oh, you write like this. Actually it should be like this. Okay, there is no overlapping. You write 4 circles, they just touch to each other. There is no overlapping. So they are maximum close to each other in this type of cubic cell. Then internuclear distance is measured, but internuclear distance is as good as age length. Now see this diagram. See here, internuclear distance, it is age length only. Okay.
So ma'am, what type of questions will come in the exam related to this?
You have to learn all these things. We'll take one practice test, then you will complete.
Means will you upload the last year paper or something like that?
Yeah. Okay. First we'll complete the portion, till that you have to revise. Okay.
This is which lecture?
This is lecture 12. And yes, one more thing is that you are having portion from lecture 1 to lecture 12 only. Last time I told lecture we have kept only up to lecture 12.
Ma'am, so today we have finished the portion.
No, this is very big.
Oh, okay.
So one more lecture will be required.
लेक्चर 12 आपण लाईक मागच्या लेक्चरलाच सुरू केलेलं ना 14 तारखेला आणि मग आजपर्यंत एक लेक्चर
Yes.
बापरे खूप मोठा आहे
Screening effect shield. It is very big.
एका ह्याला एक दिवस लागेल.
Yeah.
Ma'am, can you send the previous year's question papers?
Yes.
So that means we will understand the
First
pattern.
thing is that I will send you this lecture today. Even though we'll not complete, I will send you. You start learning. You start revising. Okay.
Actually,
and next time we'll complete.
Means if you send the paper earlier, then we'll understand the pattern also, right?
Yeah, I will. I am going to send in the next week. Okay. So this is the age length. R is equal to A by 2. This is about simple cubic cell. Okay. Now I will change the page. Now second type of unit cell. Now see. There are 7 types of unit cell. Consider only first, that is cubic cell. In the cubic cell, this is the first type we have done, that is simple cubic cell. And next is face centered cubic cell, FCC. FCC, that is face centered cubic cell. Now we'll draw the diagram of face centered cubic cell. Now in face centered cubic cell, there are atoms at each corner. That is there, but along with that, one atom is there on each face also. There are 6 faces, na?
म्हणजे असं पेजच्या मध्ये का
हा फेसच्या मध्ये, फेसच्या सेंटरला पण एक असतो. सो देर आर 8 corners. At 8 corners, one atom is present, and on each center of face, one atom is present. So I have with, okay, I will write with different colors. Yellow. Can you see yellow part of it?
Yes, ma'am.
Now see, one face is above, then side below, and then one is back and one is.
Means there are 14 atoms.
Face. At the center, there are atoms. Now, how to calculate radius in this case? So here we have to.
मॅम ते डायग्राम मध्ये ते जे सेंटर मधले क्युबिक सेल्स आहेत ते बघून असं वाटत की ते एकाच ह्याच्यावर आहेत.
एकाच ह्याच्यावर म्हणजे
मग एकाच फेसवर आहे. म्हणजे ते वेगळ्या साईडला आहेत ना.
हो.
ओके.
3D स्ट्रक्चर आहे ना हे क्यूब म्हणजे.
ठीक आहे.
So how to calculate radius of this? Okay, now I will draw the diagram like this. If you consider each face from top view, you will. Can you imagine it? It is like this. Hello.
Yes. Yes, ma'am. Got it.
Very good. तुमचं जॉमेट्री चांगलं आहे.
8th स्टँडर्ड मध्ये फक्त जॉमेट्रीच आहे ना मॅथ्सला.
येस, करेक्ट.
राज सरनी शिकवलंय.
व्हेरी गुड.
म्हणून भारी आहे.
म्हणून काय?
भारी आहे.
म्हणून भारी आहे. अरे वा, मस्त. केमिस्ट्री आहे का भारी?
हो, छान आहे. जरा अवघड आहे पण छान शिकव.
काय?
अवघड आहे जरा पण तुम्ही छान शिकवता, म्हणजे असं कळतं. परीक्षेत नाही माहिती कळतं.
मॅथ्स आणि फिजिक्स सोपं आहे. केमिस्ट्री.
केमिस्ट्री अवघड आहे.
नाही मॅम, दोघांना सोपं आहे.
ओके.
ठीक आहे.
आणि तुम्ही शिकवता म्हणून अजून चांगलं कळतं.
व्हेरी गुड, थँक्यू. ठीक आहे. So face center cubic cell. So can you imagine if you top view or side view? So there are 4 atoms at 4 corners, and at the center one atom is there. Okay. Now suppose if you draw triangle like this, triangle ABC, then do you know that AC square, that is hypotenuse, AC square is equal to AB square plus
BC square.
Yeah. So what is A square, that I will tell you. Now see, suppose if you consider only this part, then that is R. Now the middle atom, this is 1 R, again R. R is the radius and this is R. So the length AC square is 4R. 4R square. Have you followed this concept? How it is 4R?
Yes.
Followed everybody?
Yes, ma'am.
Very good. Now what is AB square and BC square? AB, who will tell?
Ma'am, 3R and
No, that is A, age length, and BC also age length.
AB square is 2R. 2
Yeah.
मॅम म्हणजे
So AB
आयसोसेलेस
square,
ट्रायंगल झाला. आयसोसेलेस ट्रायंगल झाला.
yeah,
Isosceles right
but
angle.
90-degree also, no?
Ma'am means isosceles
Oh,
90
triangle.
by
45,
45
90
is
झाला.
right
Yeah,
angle.
correct.
45,
So
45,
AB
90.
square, yes, correct. So AB length, AB is A, age length, A square plus BC square, that is also A square, right? So 4R square, that is 16R square, is equal to 2A square. Followed? So what is R? R square is equal to 2A square divided by 16.
R square equal to A square by 8.
No, R is equal to root 2 A.
असं नुसतं R का? मला वाटलं
Because we have to find out radius now. So root 2A, therefore
A
R is equal to
root 2 by 4.
Yeah. Square root, in the square root only 2 is there, not A. Root 2 into A divided by 4. This is the radius of FCC. Radius
त्याला
of
आपण
FCC.
पण आपण त्याला A root 2 असं पण म्हणू शकतो ना.
हा, चालेल ना, काही प्रॉब्लेम नाही. A root 2 पण म्हणू शकतो. root 2A or A root 2, काहीच प्रॉब्लेम नाही. Upon 4. Yes.
Ma'am, हे दर FCC same.
Oh. Whenever there is unit cell like this. Whenever there is unit cell like this, then R is equal to A root 2 upon 4.
म्हणजे आता एज लेंथ वर डिपेंड करतं. एज लेंथ वर त्याची व्हॅल्यू डिपेंड करते ना.
बरोबर आहे. Correct. Age length वर. So have you followed FCC?
Yes.
Okay. Now we'll start third. That is BCC. Body centered. Body center cubic. आता नीट लिहित नाही आहे. Body centered cubic cell. Okay. Again we have to draw the diagram. Body center is little bit difficult.
मॅम एकदा मागची स्क्रीन दाखवा ना. हा झालं.
Now in case of body centered cubic cell, there are atoms at the corner. Who will tell what will be there?
I think तो पूर्ण तो क्यूब आहे त्याच्यामध्ये मध्ये असणार सगळ्यात मध्ये.
मॅम किंवा लाईन्स.
नाही, at the center of the cube one atom is there. That is body centered cube.
मॅम तर तिन्ही याच्याकडे व्हर्टायसेस आहे. ओके, ठीक.
Now which is the situation when atoms are most close to each other? Which is that situation?
मॅम FCC असेल ना.
FCC. FCC.
No. What I am saying, that is in BCC, what is the situation where atoms are close to each other? So these three, na? These three.
yes. Diagonal holds.
Yeah. So we have to draw the diagram like this. Now see, this we have to join diagonally. Okay. And then we have to join these. So we have to consider here two triangles. We have to consider two triangles over here. Now again I will okay, suppose this is A, then B, and then C. So I will, for your understanding purpose, I will write this A, B, C over here. Okay, and then again I will write this. This is D, suppose A, B, and D. So first we have to calculate this length. Now this BC is A, edge length. AC is also edge length.
AB is A root 2.
So first situation, AB square equal to AC square plus BC square. So it is equal to A square plus A square. It is equal to 2A square. Therefore, AB is equal to root 2A. Followed? Now we found out the value of this that is root 2A over here. Hello? Have you followed that?
Yes.
Now see, this is root 2A. That is the length AB. Now what we have to find out? We have to find out AD. Again, BD is A. Now see, BC is A, right? AC is also A, edge length, and BD is also edge length. Now see, so here it is edge length. AB we have calculated root 2A, and we have to find out AC now. Now see, what is the situation in AC? One atom is here, middle atom is
मॅम ते एडी असायला पाहिजे ना.
हाँ, इथे AD आहे, correct. इथे AD आहे. Yes.
Actually, properties म्हणजे diagonal of a cube is A root 3.
Now see, this is D. Okay. So can you imagine this situation? Three atoms are in one line. Okay. So what you can say over here? This is again R. This is R. This is R, and this is R. Again, this is AD equal to 4R. AD is equal to 4R. Followed this situation. So second calculation is AD square is equal to AB square plus BD square. AB we found out, that is root 2A square plus BD is S square and AD is 4R square. Will you calculate the value of R on your own?
Yes.
Yes.
What is value of R? Now see, this is 16R square is equal to 2A square
root 3A by 4
plus S. Correct. Very good. So it is 3A square.
√3a ना?
Yeah, correct.
√3a by 4.
√3a by 4, correct. √3a divided by 4, that is r. So you do one thing, you have to make one table, that is homework for you. That is what you have to do. First is BCC. No, first is say SCC, simple cubic cell. Then FCC is there, and NCC is there, and you have to write the radius. In SCC, okay, we'll complete a by 2. In FCC, what is that? FCC मध्ये काय?
A root 2 by 4. A root 2 by 4.
A root 2 by 4. And in BCC?
A root 3 by 4.
A root 3 by 4. Correct. झालं तुमचं इथंच टेबल तयार झाला. Okay. Followed?
Yes, ma'am.
This is unit cell. And this is R. R is the radius. In one table, all the habit of writing, then you will understand it better. So during the exam, if you see the first year to study complete thing, but you know before exam, if you look over the things like what is the summary, then you will get it, you will understand it better. So have you copied that, and shall I end the meeting now?
Ma'am, can you show SCC slide for SCC slide?
I didn't get
FCC slide.
FCC.
SCC.
You have to see or what? FCC?
Yes.
Okay.
Ma'am, SCC, simple cubic cell. Thank you, ma'am. Done.
So this is about
Ma'am,
metallic radius. This is the metallic radius. In metallic radius, we have seen that there are 7 types of unit cell. Now in the first unit cell, again there are 3 types. In simple cubic, there are SCC, FCC and BCC.
प्रत्येक टाइपला किती आहेत तसे सबटाइप्स?
ते आपण नाही बघायचे आता. आपण फक्त सिंपल क्यूबिकच बघितलं, मगाशीच मी सांगितलं. इथे खूप वास्ट आहे आणि ते 11 12 मध्ये असतं. आता 8th स्टँडर्डला फक्त तुम्हाला सिंपल क्यूबिक आहे. And in simple cubic, again there are 3 types we have completed. So I will end the meeting now, okay? And I will send you notes also. Bye bye.
Okay, bye ma'am, good night.
Okay, ma'am.
Bye, ma'am. Thank you, ma'am.
Okay, bye bye. See you.
Thank you.
Bye bye. Good night.